So I have to cover a few things that are not, they're a bit of extra syntax that is not like advanced operators. So we'll talk a lot later about advanced SQL operators, including things like the fancy joins, not just natural join, and things like window functions. So that'll happen sometime after exam 3. But I do have to talk about a couple of things, so I'm going to make a short, I hope it's short, a short video talking about some other weird syntax. It's not relational algebra specific, it's just SQL stuff that we might need, or I think one of these is actually already shown up, depending on what order you're watching this stuff in. And so I just want to have it in there to be some place where we first see these features. And so none of them are terribly exciting. It's just good to put them somewhere. So the first one is we're used to select statements that look like this. Select star from products, for example. So I run that, I get this. I could do select star from orders, great. And I get the predictable results. I'm on the fruit database as usual. Maybe, I don't know, we get a bit attached to SQL statements having a from clause. But to be clear, we don't actually need even a from clause. It's completely valid for us to have a select statement with nothing but the column selection clause. Now you think, how am I going to do that? I mean, how do I select name from nothing? Well, the answer is, if you think about what you're allowed to select from tables, so select name from products, there you go. I could also select... well, still from products, I could select, or actually let's try this. So from my order contents table, I'm going to select the number of kilograms bought. And that's the number of kilograms bought, great. I'm allowed to select that times 0. In fact, I'm allowed to select any arithmetic expression I want. We'll notice that it doesn't even know the name of the column at this point because I didn't give it a name as 0. Okay, great. I'm also allowed to select something that gives me only a single row as my result. And so one example, we've actually used something similar already, is I'm allowed to take a sum, which is an aggregation function, without grouping. And if we do that, we just compute the sum, we aggregate as if there's only one group, which is everything. So what's interesting is I'm allowed to use arithmetic expressions for column names, even if I don't have a from clause in my statement. So I could select 6 as my number, or I could select 6 times 5 or something, 6 times 5. So if I do this, I'm running a valid query. I'm not getting any tables, doing any grouping, using a where clause. All I'm doing is selecting the single value 6, the scalar value, and giving it a column name, my number. If I want to, I'm allowed to select, an arithmetic expression, but I can select anything else that is a single scalar value. So there's a few examples of this. We'll come back to this quite a bit later. We'll spend a lot of time with stuff like times. But just to give an example of at least one other function that returns something, there's this function called now in Postgres, and it returns the current date and time. And so it's currently, about 1:30 in the afternoon on June 6th. And we can see if I do this, I'm calling this function. It doesn't retrieve anything from a table. It's just basically doing it's just taking the system clock and telling me what the current time is, or the current time on the server. So I have that option. I'm allowed to do that. Why do we care? Well, there are times when we need some value to have, we sort of want to construct a table with one column and one row to maybe join to something else. And so we can do that. And that plays into my next issue, which is, suppose that I'm sitting inside a database, like my fruit database, where I've got these 3 tables, products, order contents, and orders. But I think it would be really helpful if I had a brand new table that had a certain number of rows, and I already know their values. Maybe I want to do a join, maybe I want to do something else. But I can't just go adding tables to my database, because that's a heavyweight operation. That's storing stuff on a disk. But if I think, hey, this query would be way easier to write if I had some, phony table I could cook up with specific constant values in it and multiple rows. That does happen sometimes, and it's really powerful in some cases. There'll be queries we see in this course where if you used a trick like that, you could get the query size way down. We have an option to do that. So I'm going to do select star from, and in my from clause, I'll put it on the next line, in my from clause, I'm going to give a weird bracketed expression. And specifically, I'm going to put in values, and you might remember the word values as a keyword shows up in the insert statement. So I'm then going to give two tuples, 6, 10, 17, 187. And this table I've just constructed, so the values keyword is saying take the tuples I give you and mash them together to look like a table. I'm going to take the result and I'm going to give it a name, like Postgres requires, but I'm also going to do this. When you rename a table in a from clause, you are allowed to also name its columns. And when I have a temporary table that I've just cooked up from scratch, I better give the columns names. Otherwise, what is the name of each column of this result? I'll put the results on separate lines to make it more clear what's going on. So I'm going to call it points is the name of my fake table, and X is the name of the first column, and Y is the name of the second column. And so we'll try running that. And we can see that the result, the database server gets that and it sends back X, Y, and then 6, 10, 17, 187. And so if I need an extra table, often you need it because you want to join it to something. You want to do it, you want to pull out a set of particular rows. Instead of doing a complicated where clause, you can often do a clever join against one of these. You have the option of cooking up a synthetic pseudo table whenever you want with whatever data you want in it. And then there's this. So of all of the things in this document, this last one is probably the most important one. It's the most bizarre looking one, I guess, but it's also the one that's most likely to be useful. Here's what it's asking you to do. It's saying, so I want to do select star from products. Okay. And I would like to take all the products whose names are raspberry, and I want to construct a result that contains two columns, the name and is delicious. So the product name is raspberry. I want to say that it is delicious. If it's pineapple, I want to say that it is not. And I want to say maybe for everything else. The issue here is that what I'm doing is basically discrete cases. I would like to do basically an if statement. I want to say if the name was one thing, do this. If the name was another thing, do this. Else, do that. And we have that feature in SQL. We have this expression. Maybe if you're familiar with the ternary conditional or something similar in C or Java, it's sort of closer to that because it's this inline if statement. It evaluates a different expression depending on which case you fall into. So I'm going to start by doing select name from products. So there's my product names. Okay, I've got one of the columns I want. And then I'm going to use this case when. I'm going to put the column selector on a separate line for the sake of it being a little bit cleaner looking. Okay, so what I have now is what's called a case directive in SQL, and it has to look like this. So the brackets are actually optional, but I just can't handle it without them. So case and then end. And remember that the white space is also optional. And I often don't use as much white space as I'm going to use here. So between case and end, we have a sequence of different cases, and we preface them with the word when. And just like the except operator, this is one of those weird bits of baggage that comes with SQL being the age it is, which it probably inherited from the tradition of languages like COBOL that made an attempt to look like English. So when name is equal to raspberry, then I want the expression to be the string yes. When name is equal to pineapple, then I want the expression to be the string no. Else, I want the expression to equal the string maybe. So what happens when I get into these brackets is we evaluate each case in order. We say, is the name equal to raspberry? If the answer is yes, then this is the result that comes out of the brackets. Otherwise, we keep going. It's like if and else if. And that means if something down here, if this also said raspberry, we'd never hit this because we already hit it up here. So it's just like an if and else if chain. And what ends up happening is I get some value coming out of these brackets. We have to make an effort in a tight system like Postgres to make sure that the type of all of the values that could come out matches up. But usually if we're using this, then that's what we want. So I'll try running this. And we'll notice that by default, so it does work. Raspberry, yes. Pineapple, no. Everything else, maybe. By default, the column gets a sort of made-up name. It's just going to be called case. I obviously want to rename that column is delicious. Okay, great. So I have this. So the reason why this is important, and it's going to show up in our long sequence of applied SQL examples in a couple of places. The reason why this is important is there are places where we get discrete cases. And there actually are ways this particular example could be written without using the case when directive. And I will not do it, but I will summarize how you do it. What you would do is you would take the products table and you would select out all the things where the answer is supposed to be yes. So you'd select where name equals raspberry. Then add a new column whose value is always yes. then make a separate query that did the same for pineapple and set the value to no, and then a separate query that selected everything else and set the value to maybe, and then union them all together. And you might see that's a big mess. You could do it, and it's worth trying it for the sake of, developing some dexterity with set operations. But this is a much easier way because fundamentally you've got a bunch of discrete cases whose identity is sort of superficial. They're not completely independent discrete cases. They're related to this name attribute. And so it's pretty easy to just bunch them into an if-else statement like this one. Okay, so we have that. So now you can go on and take a look at our sequence of applied SQL examples, which will carry us all the way up to exam 3. And we'll notice there's a whole bunch of other SQL syntax we're going to learn, but most of it's actually, interesting operators that do stuff, not funny language features we can use to make our lives a little bit easier when we write queries.